Okay, let's quickly start with day 9. See, first we're gonna have a quick peek here and here and here. Oh, Lucas has fixed it. Doogie has done it. I am so lagging behind. Okay, quick for some points, huh? Encoding errors. I'll just pause the recording while I try and understand the puzzle, and then we'll continue hacking away. Okay, that's basically decoding some data and finding the first ROM occurrence. I don't want to mess about with the example things, so we'll just get straight to our puzzle input, which is humongous, as usual. So VI9 and paste that. That's funny. Copy and paste it in. Those are some humongous numbers. Those are. Get out of there, log on to TSO. You don't need to see that while I'll prep the thing. Okay, so we have all the files prepped and the initialization and opening the file and reading it into a stem, and we're gonna read that into an XMAS stem, I think, in line with the puzzle. So basically we still do this traditional loop, just click on right, it's 1, 2, XMAS.0, and then we do have a what they call preamble. I'll just short it to pre, which is 25. In our case, that means after the 25th number, we need to find a number or two numbers in the previous ones that add up to the one that we're reading, and find the first one that doesn't match. So we can guide through that, and the preamble is 25. Our current is there. So if our current position, get out of the road, that if our current position is less than or equal to the preemptive, do then iterate, right? We don't need to do anything. Then we end up to 26 in our case. So get rid of that. Let's see. So what do we need to do? We need to find two values that add up to that number. In the previous 25, so 25 back from I. So we need to, weirdo. We need to find XMAS.I. Let's comment it out first. Find two indexes whose values up to XMAS.I. To XMAS.xy values added up to XMAS.I. So we have a subloop. I think we have a subloop. Okay, then we have a little break in between, but that's okay. We just need to find those two coordinates. So we have a loop here, J loop, but that's not from 1. That is 25 back from our current. So not this one, but I minus 1, 2. Our preemptive back. Probably right. I minus pre. Let's just see if our logic clocks. I'm at I and need to look from. Oh, we don't need it. And look at range. Let's do that. Look at J. Let's just see if that goes well. Yeah, that sounds good. Do that. That sounds good. Gotta get that attention key up there too. Totally doesn't look good. What are we missing here? friend trace, huh? Oh, we need to swap those over, of course. We're doing it the wrong way. Attention key, I. Because I minus 1 is in our case 24, and that one is 1, so we need to flip that around. Loop in the right order. Yeah, that's good. Attention. Right, get that trace out of there. Print that as a variable, not as a string. 1 to 25 and then 2 to 26. This is good. This is what we want. And then we need to repeat that loop again. It's going to be very loopy, probably terrible. We call that x, y, so we better do this. X, but we have a loop in there. Do y equals, and we can't then use the same one as that one. So what is smart? We go from x, x plus 1, and we check all the next ones. No, do the same range but not ourselves. That sounds more sane. So we do the same thing. I minus 3 to I minus 1. If x I equals x, then iterate, skip that one. Otherwise, if x plus y equals y, then we have found our thing. Up. Found 0. Found equals 1. And then we can leave this loop. Then we leave the y loop. And we also leave the x loop, so we don't want to count too much. We might need an extra break. Maybe we don't need this, maybe we can fool ourselves and say, so if we found one, we are done with this one, so we can just say that we break this loop, we want to break this loop, we basically want to go to the next for this, so this one leaf isn't enough, and we do need to find is 0. So in this loop, I'm just going to do if leave. I'm going to do the same here. So we either go through all of them and we end up here at the end of this whole bunch. And here we say if found equals 0, then do end say index I. We can't hide to add up. What is it precisely? When the first number that does not have this property. Say the number is XMAS. Well, fingers crossed. I thought as much happened. Having running in, oh, that's because we have that X and it thinks it's hexadecimal stuff, and it's annoying. I'm looking at 1 and 12 is 13. Let's make that a bit shorter. I equals I. Oh, we're missing some ends here. I do. We're missing an end here. Two ends. Do and jump in indent. Triple output. That easy? Already at the second one. So would our answer be 58? That would be easy. No, thank God we're wrong. I equals 26, let's do the rough data. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Don't need to do that. I equals 26, I need 13. That is this one. So I need to find 13 as a sum of previous these two ones. I think my code is just doing things the wrong way around. That's what I think. So let's read it again. Duh. That looks better. Quit that. Get rid of that one. Get rid of that one. Easy. Oh. That kind of makes me think this is our answer. Woohoo! Part 2. Now we need to really break the Christmas encryption until we get beyond it. We get the second one added to okay. Attention. We're gonna do this on the same one. Say the number is x y, and then we can stop. Right, we can leave. Not before saying invalid number equals x must have y, x must have y, and then we go out of there and we say now no and 2, 4, no. Yeah, okay. But we do start at the first one. We do have the loop. Do I equals 1 to x must have 0 end. That starts us at the first number. And we say the sum equals 0. No, sum equals x must go 0. And then do forever. We keep adding things. And then go to the next one, but it's not forever, it's at a maximum to the thing. So do j equals 2 to x must go 0. Smallest and largest number in this range. Okay. Weird. So So we just first add it, right? So sum equals sum plus XMAS.j. That's what we do. So then we add 20 to 35. And we have to see if sum greater than our invalid number. Then we're basically done. Too much. Go to next. We can delete that later, but we can leave here. No, we just write one, yeah, leave. And if the sum equals our invalid number, then count that number, and say we want the string. Continuous range from A to B. And of course we don't have A and B yet, so we'll say A and B, but let's see if we find it. Then we can worry about the other thing. Invalid hexagon B, D, E, sure. Let's do this. That, and it should work, I hope. Too much go to next, too much go to next. Let's get rid of that message. Or not. Does it make sense that we hit that too much very fast? Probably goes really fast, right? It probably goes really fast. Wait to delete this. Nothing is correct. Pause again. Haha. Okay, so of course over here we shouldn't do 2 but I plus 1, and so we start from the next one up to where we start. And we're making that range bigger, and then we found the range to be from I to J, I think. Do A equals 1. No. I to J. Our minimum number is a very large number, and our maximum number is a very small number. And then we say if our XMAS code point K is smaller than our minimum number, then min equals XMAS.K, and if our XMAS.K is bigger than our maximum number, then our maximum number is XMAS.K. I think min and max are not protected words, so we're going to do small and large. That sounds good. Small, large, small, large. Then we're done, and then we're going to say small equals small. Okay. Large equals large. Say answer part 2 equals small equals large. We can call it a day. That goes the wrong way around. We made a thinking error. If xmas.k is less than small, let's see if it's bigger than large. There. So we take this one, copy it, hopefully get our points. Oh yeah. Immediately share that out. Maybe upload this video, maybe I won't. Hashtag REXX. Hashtag coding fun. Tweet.